Okay, I think we'll get started. So Fun Lab today, we are going to put together our previous labs from the on the UART Universal Asynchronous Receive and Transmit Protocol. And so now we're going to both send and receive data interactively between the computer and the PIC. And we're just going to make a silly little guessing game. We're going to choose a number, an 8-bit number between 0 and 255, and then we'll tell the PIC, okay, start to guess, and then the PIC will send a guess, and then we'll say too high or too low, and then the PIC will modify its guess. Nothing new if you've seen the other labs, but working with a lot of the UART registers, and so you can look at those other videos to hear our more detailed discussion of these, although I will talk a bit about them as we go through the code. As with the others, you'll need this USB to UART converter. So I talked about that in the first of the UART transmission videos, but it's this nice, I'm using this nice little $9.99 one from Amazon. But any USB to UART converter will work. Then we need a computer with Python, and we're going to just use Thony as our IDE because we're just the programs are pretty simple. I've got both of course I've got the assembly code on the GitHub page or the GitHub repository, and also the Python programs. All right, very simple. We're just going to use the UART in and the UART out on pins 5 and 4. Now, the guessing strategy, as you might expect, very simple. The first guess will always be half, and then we're going to split the difference as we go too high, too low. So we're going to guess 127, then we'll refine that guess by adding or subtracting 64, then updating that guess as either 127 plus 64 or 127 minus 64. Then we will refine our guess further by adding 32. So we'll be cutting that difference, and we're calling that the guess step size. The guess step size will cut down in half each time. And let's look at an example. Let's say we choose 47, secretly choose 47. The PIC makes a guess at 127. Well, that's too high. So then it'll take 27 minus 64. That'll be 63. That's still too high. Then it'll be 63 minus 32. Well, now that's 31. That's too low. And then it'll be 31 plus 16. And in that case, it got 47. And it'll just keep going. It might go all the way till it's just making a change of 1, but eventually it'll get the right answer that way. All right, so let's see how this works. I think what we'll do is we'll do the game first, and then we will go back and look at the code second. Okay, so here we are with we're gonna run two programs here with Python. This first one is going to be kind of as I described it there. We're going to give a guess, and then we're going to say that's too high, that's too low, and then we'll have another program where it will just automatically play by choosing a random number and then going. All right, so let's just try to run this now. There's nothing really to see here on the. I don't have this decorated with any LEDs. That could be something you could do as a augmentation. We will see a green LED on this flash when it's sending or receiving data. So let's go ahead and run the Python program. And so I'll hit run. Uh-oh. There we go. Oh. I'm going to escape from this. Sorry about that. I think I ran the wrong one. So guessing game 2 is what I want. All right. Okay, let's go ahead and start this. Okay, so I know it's kind of small here, but hopefully you can see this. Guess a number between 0 and 255. Well, let's try that 47 that we had first. So then we'll hit 47 and hit enter. And so then it sent a signal. So this is going to just send us, it actually just sends a binary 1, and that will tell the PIC to make its first guess. Now the PIC is just sitting in a waiting loop, waiting to get another transmission. And so we're going to say, this is your guess. Is the guess too low or too high? So it's too high. So we're going to, sorry, yeah, it's too high. So we're going to press A and then enter. And now we should see it guess 64 lower than this. So we should guess it comes back here with a 63. And now we're going to say, well, that's still too high. 31, that's too low. And then it guessed it correctly. Okay, so let's go look at the code, and then we'll come back and play this one more time, or a couple more times. Okay, so here with the code, the configuration bits, same as we've always had them, no changes there. The include file, and the PSECT directive, all the same as we've had before. Again, sections to this program. Now there's more sections here, so I'll go through those. Maybe I'll go through those now just to give a layout. So the main section, this first section is just going to be stuff that never changes, so we have that before. And now we're going to have this start loop come first. So in the start loop is sitting there waiting for the game to start. So that's when we would, right after we would press the button that we have chosen our number, and after we've hit enter when we've chosen the number, then it sends, the Python program sends a program, and this is sitting here now waiting for the flag for and this is 5, this is the RCIF. So this is, have we received a bit of information, or a byte of information, so 8 bits. And so if so, then this flag will go and we will skip out of the starting loop. If not, then this will just keep running like this until that happens. So we come out of the starting loop, and now we have to switch to the bank that the UART stuff is on. So I think that's bank 3 or 4, I think 3. But we have this bank select directive that is helpful for that. Now here is something I chased my tail with for hours yesterday. We are going to use this value, but it stays, so I didn't know this, but it stays in the register indefinitely, with then having this flag set as 1. As soon as you read the data, so in this case not read the data like let's read one of the bits, but read out the whole information by moving that to the working directory. Then the bit this flag clears. So if you were to just check a bit in there, it wouldn't clear the flag. It wouldn't be ready to receive another byte of data. So this line, although it doesn't see, we're not going to really use this. It has moved this to the working directory, and thus it has reset this flag. So when we come back after the guess, we want to come back into this loop. We don't want to, we're in the start loop. We won't use this here, but we don't want to continue to see that flag as we get to the wait loop. Okay, so now we're going to move the literal 127. So this is binary for 127. We're going to move that into just one of the memory registers. This register is in bank 0, so we'll keep it right here with port A. And then our guess step size. Now this is this is 64. So this will this is 120, 128. So it seems like it's too much, but we'll see later this is the right thing to do here. So we're going to initialize the step size as 128. Okay, so this is that start bit. Now, once we've started the game, we want to just stay in the main loop. So we're going to enter the main loop, and now we're checking here, or no, we're not checking, we are sending our guess here. So we're ready. This is checking whether the TRX is empty or not. And so when we load into the TX reg the guess that we're going to send, then this will offer the flag. So we're going to now move the current guess into the working register. This is the current guess. In this case, it's still that 127, but we want this to be updated every time. So this is going to be our current guess, and we will now load this into the TX reg. So this is the register that the data are transmitted from. Okay, so in this case, we transmit out the 127. Now we go into the wait loop, and so this will just spin here until we answer with an A or a B, as we did in the program. And once we do that, it has received that information. And so this is where I was having trouble. It was not staying in this loop initially because we never cleared this flag up here, and that was the problem. So this line up here is needed so that this flag is 0 when it's still waiting. So that needs to be cleared. Okay, so now we've received, so we pop out of the wait loop. Now we switch over to the memory bank with the step size, and we're going to rotate this right 1. And what rotate right does is it slides to the right in the register, and then in the most significant bit enters a 0. So it doesn't roll around, it just slides, and it keeps entering 0 on the most significant bit. So what that does is it divides by 2. So basically it's dividing by 2 your number. So it's going to take our number that was 120, and that's why we had to have 128 here. And it's going to take it, slide it 1 here, and so that'll be 64. All right, so that's why we had to start with our step size one division further, because this happens right after we leave the wait loop. Okay, so now we're going to we're going to move this to the working register again to clear this register. Now we're going to read from the register. We're going to read the 0th bit, and this is we're taking advantage of, if you did watch the receiving UART video where we sent an ASCII character and then looked to see if it was odd or represented by an odd number or even number. That's basically what we're doing here. So it's going to check the least significant bit, and if it's a 1, it's odd. If it's a 0, it's even. And so that's going to allow us to split into the 2 branches, the 2 low branch and the 2 high branch. So this is either going to be the 0th bit of this is going to, right here, the 0th bit is either going to be set, in which case we sent an odd number, or clear, in which case we sent an even number. If it's set, we're going to skip the raise guess, and we'll come down here. It's set, so we won't skip this. We'll end up with the lower your guess, and vice versa. So this is how we branch into the 2 guesses. I'll just finish this bit off, so then there'll just be a little bit of a delay, and then it'll swoop back up to the main loop and just sit here waiting for the next response, and then the whole process will happen again, in which case every time through the loop it will shift that step size by 1, thus dividing it by 2. So it'll be 64, 32, 16, and so on, all the way down to 1. Which in that point, then it'll eventually get the right answer somewhere along the way. Okay, well, now let's jump into these two functions. Pretty easy. We are going to move the step size to the working directory. The reason we have to do this is there isn't a command that will add 2 registers. So you can only add a register to the working register. So we have to put one of these in the working register. So we'll put the step size in the working register. Then we'll use the add function to add the working register to the current register. And the 1 here will say, then put the result back into the current guess register, not into the working register. So if this was a 0, then it would put the result into the working register. But we want to keep updating the current guess register, which is this at address 020. So that is set to 1, and that tells us that we end up putting the result there. Now, the lower guess, very similar. We're just going to subtract. So we're going to put this into the working register, and we're going to use the subtract function. This always subtracts the working register from the file from the register that you've indicated. And so that's why in this case, we do have to put the step size into the working register. And so we do that. Again, put a 1 here, so that means the result gets put back into the 020 register. In both of these cases, we return back to where they came from, and so we'll move through the loop. And so that will update this, and then when we come back through here, we will send the new guess, right? Because this will go back to main loop, and whatever our current guess is, not start loop, but main loop, we will send that, and then we'll go into the wait loop. Okay. All right, so that's the code. A little bit of logic there. So it was a good example of a case where it really was a good project because, one, I didn't know about this flag thing, so that was something that I was able to figure out. And then just having to think about how to get all the logic to work in the circuit is good. And then it also then gets the two UART send receive being used together. All right, let's just run the, and you'll notice here, this could be a challenge for you. See if you could put a little reset in here, like either a button or something in your circuit to reset the game. I'm going to just I'm just going to unplug it and plug it in so that we can reset the game. Because, yeah, let me not do that yet. Let me run the program again. And we'll see that it's going to guess what was currently left in there. So I'll go ahead and run the program. Let's just say 111, and there it guessed. I don't know. It just shows it's not at the beginning, so that's why we have to reset the PIC. And so you could do this a number of ways. You could use the master clear reset. You could just put a button here on one of the pins and pull. But I'll let you try to do that as a challenge. Okay, so I'll just unplug this, plug this back in. You can put as simple as a switch on your power supply, whatever to restart the game. So let's go ahead and restart this. Let's try 111 again. And that is too high, so we're going to press A. Now that is too low, so we're going to press B. That's still too low. Oops. And then it guessed it correctly. Now let's do another program that's there on the GitHub site, and so let's look at this. I'll actually go through the structure here a little bit. So we have to choose the correct COM port here on my machine. It's COM4. You can find that by, let's look at Device Manager. And if you look at your COM ports, this USB to serial is what you're looking for, and that will come up automatically for if you're in Windows 11. With Windows 10, you have to do some stuff, and I was never really able to get it to work correctly. And then if you're in Unix, that'll work just fine. Apple, I'm not sure. I've never really worked with a Mac or an Apple machine. Okay, so COM4, baud rate very low here, but plenty fast for this game. So the baud rate is at 301 actually, and then we have just a way to escape the game. That's just this part, and then this is going to generate a random number between 0 and 255, and then this sets all the baud rate, stuff like that. This will send the start signal, and then here, this while loop will just keep running, and it will be sending a 0 or a 1, depending on whether the guess is too high or too low. All right, so let's go ahead and run this. So 80, 127, too high, too low, 95. Well, this looks like this might be one that will take all the way to the end. Yep. So it took its final guess, and it got it. We'll do just one more, and we'll call it good. Random number 123. Oh, this would probably take most of the guesses too, because it's so close to that first guess. But we'll see. Oh no, it didn't. So that's this simple guessing game. It's sort of a silly application, but it does bring together some things that you might need in the laboratory. So a good project to work on. Then challenge yourself by trying to tweak it a little bit and get it closer to the needs that you might have for either your lab work or any of your hobbies. All right. That kind of does it for the UART capabilities for the PIC12F1822.